I'm Jason Harris. I'm a senior developer for Wolfram Research. I'm going to be talking about authoring content for the Wolfram player for the iPad. I'm going to be going into a lot of detail about authoring more advanced packages for the actual player, and a lot of details to do with loading up packages and other advanced topics. Thank you. Okay, well, I'll go ahead and get started. I'm Jason Harris. I'm a developer in Wolfram Research. With Rob and the others, I work on the player, and before that, the main front end. So you've seen it. It's here, the player. It's fantastic. It's occupied the last, 7 years, 5 years of our lives, and we're all very proud of it. And it's been a real pleasure to actually work on, to actually get it to go. It's been kind of daunting, but it's here. It's great. It's fantastic. So you've seen Rob's talk. And he's demonstrated a lot of the functionality of a normal sort of player application. You've got a notebook, you've got some controls, maybe some manipulates, some titles, some cells. But the question I'd like to sort of address now, and it's for us, now that we've actually got it, how far can we push it? We want to do complex sort of calculations. We want to load a package. How do we get it going? How do we build up something where we have a collection of notebooks that are linked? How far can we push it? And that's really the sort of topic of this talk. Okay, and so during this talk, I'm going to use one of the examples. I'm going to build up to this example in peer-to-peer lending. So the talk is somewhat schizophrenic. It's somewhat split. I've been interested in peer-to-peer lending myself. I've pumped some money. I've actually spent some of my hard-earned cash on peer-to-peer lending. And so I've written some simulations of this, and I've got a package. And we want to build up some of the tools we need to be able to actually visualize some stuff to do with peer-to-peer lending on the iPad. So manipulates, I'll mention, you've seen them with Rob's talk here. We go, and here's one of the talks that we've got. One of the notebooks that we used in our development. And of course, a normal notebook is just an NB. You can scroll it. It's got nice typesetting, so on. This is a kind of normal application, and it's got a manipulate here. And we've got this control raft down the bottom, and we can move it onto the right side or top, left, and bottom. And the controls work, and we can visualize here's a nice line integral, and so on. So that's the kind of standard notebook, and so I won't talk about that too much. I'll then move on to the iOS player, and I'll mention, if you've been in Rob's talk here, there's some specific things we've done for the player, like the touchscreen control placement, so we can put the raft instead of on the bottom, on the right or left. The touch position, locator magnifiers. Rob didn't talk about that, but that's also specific on the player. And in fact, there's a whole host of various options we've done and customization we've done for the iPad version. And so I will say, since it's taken us 5 years, you might think, well, Jason and Rob are just kind of stupid and slack, but indeed it's actually not the case. In fact, there's a whole new core that's underneath this. And so this core, it's multi-threaded from the ground up, and its architecture is, it's quite a nice modern architecture, and this allows us a lot of improvements. And of course, we've got the fantastic front end that, if you went to John's talk, is like maybe 21 years ahead of everybody else. And so, of course, with modern systems, you get desktops with maybe 16 cores. And so we need multi-threading at some stage. And so we'll be bringing back some of the advances we've got in the actual player to the main front end, and as we move forward, and unifying them as we go. But like Rob, I'm going to point out some of the limitations, and specifically the limitations that I came across in doing this talk. One of them is the parallel tools. So since I'm running simulations, when I do this on my laptop, it took me maybe 10 minutes to run the simulation, and I did it with parallel tools, so it was even faster than that. Might have taken half an hour or 40 minutes or an hour to do my simulations, but I can't do them on the iPad because, of course, and on my version here, everything is all in the same processor space. So the front end and the kernel live in the same processing space, and so I can't use parallel tools. For saving, when we want to develop an actual application, we can't save anything on an iPad, so we need some sort of persistence. So we handle this in a way which I'll talk about in a bit. Notebook programming as well is somewhat limited right now on the iPad. This will be something we'll be improving in the near future, working on it, and so we'll have the full capabilities of notebook programming, hopefully, not too long from now. And then you come across other various issues that are more advanced. So for instance, I came across that buttons with method queued don't actually work. Right now, all of our controls, we use the normal standard preemptive link to send our various control interaction with the kernel. OK, so given those limitations, let's actually take a look, and let's actually mention that right now on the iPad here, we have Apple's really now actually even talking about the local file system. So my iPad really has a local file system, and indeed we'll be changing our file browser possibly at some stage in the future to enable to work with that file browser. But one of the ways we can actually get content on to the iPad, I won't hook up my laptop and show you because I'd have to fiddle around, but you do this thing that Apple calls side loading, and so you load this up and you see it's Jason's iPad Pro, you click on Wolfram Player, and over here we see the various documents. You just drag and drop some various documents there, and indeed we can actually see here's the simulate p2p.m. That's the package we're going to be playing with. Here's my title, or my talk, and there's some other sorts of stuff on the iPad. So it's pretty easy to actually get your content on. So we can get collections of notebooks that we need to do complicated applications. So now, and in fact, I'm going to pre-announce that there's one bug. So this isn't actually the shipping version. This is a bit more advanced. And there's one bug that I couldn't get fixed in time to do with cell grouping. So when I print things locally, it's going to open all the cell groups. And so, but we'll just live with that. And then I'll be able to demonstrate all the various bits. And so for an application, we need some local persistence. So here's just a slider, dynamic NN. And right here, we're using this local symbol of X, and we can actually store that. And so since we don't have shift-enter evaluation, we have to basically do all of our evaluations by buttons. So I'm doing this for the illustration, but then when we come to have an actual application, we'll do it differently. But so we can actually see here, we're going to store that in. So we're going to store 6 factorial locally. And now I'm going to do the quit the kernel, which is basically just quit the application here, load it up again, our version. I'm going to do this several times to just show you I've got nothing up my sleeve here. And we're going to load up this local persistence, and we'll actually see, when we print that local value, 720, and there's the bug. So it opened all of our various sections there. Sorry about that. And there we see 720. So it's stored the value locally, even though we've quit our sessions, and even though our slider, of course, is still on 1, we've still got this value stored locally. So we need to do this when we're building up applications. And in fact, if you want to see more on this persistence, there's Roman's talk, which is actually concurrent with this, but you'll be able to get the slides for that, which will talk about this local symbol here of the storage. OK, so let's talk about actually loading a package. You saw it's now on our actual device, and we can actually say, what is the notebook directory? Where does this notebook actually live? And it's a somewhat complicated private var, blah, 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 blah. But it's here. And so as you noticed from my side loading, my notebook, this iOS applications, is right next to the simulate P2P. So what I can do is I can just file name join our notebook directory to this simulate, and then we just use the normal needs of the context, and this will actually load the package. And so we've got no feedback. We want to fix that. We want to have some feedback. But to actually see that the package is loaded, here's just a simple simulation. And I'll talk about the peer-to-peer bit in a second. But this is just simulating a basket of $5,000 invested across this grade of loans in a peer-to-peer way. What's the annualized percentage return? And we're getting 11.499% return from that. And we could simulate it again, and maybe it's dropped a little bit that time. And so we can do some simulations. The important thing is that we've loaded a package. We've loaded a package here, and so we can build our complicated applications loading external things. So let's actually now talk about the cloud. I've got my password hidden. The version I've loaded up onto Pathable, of course, doesn't have my password in it, but it's sort of embedded and hidden there. And we can turn around, and we can actually connect to the cloud. And now we can do some various cloud put and cloud get to demonstrate our interaction with the cloud if we need to. And so an application might need to call some central server, store some results, load some results. And so here we have a simple sort of button just to test it. And what we're going to do with this is we're going to do a cloud put of X to this cloud object called Mr. Cloud. So we're going to cloud put some stuff to Mr. Cloud by storing this 3 into Mr. Cloud. And there we go, we've stored it. And now we could change this button again, something else. And now we could just load it from the cloud, which is basically a cloud get on the same object. And indeed, we get our old value of 3. And so we could change this. We could store the 7 in, change this or reset it or whatever, and again, we've stored it. So now, and we can do the same thing with cloud expressions, data bins, data bin add, and so on. So basically, we can add and load or store stuff into the cloud. And of course, this goes back to John's question, or John's statement just there, of can we actually store our complete package on the actual cloud? And indeed, we can. So we don't need to do the side loading. We can just get a notebook, and we just load it right from there, a package that's completely updated all the time. And so to get the package onto the cloud, it's basically copy file. There's the path. There's the package there, and we're copying it to some cloud object. We're setting the permissions of that to be public. And now we just go ahead, and we're going to be just doing this load package as quiet cloud get of that object. There is this expand cloud object. That's just to make sure that these cloud objects have a full path in them. When I'm logged in and connected, it's just this sort of local relative path, but this expand cloud object it's in the init code. It's not too hard. So just to show you again, I'm going to quit the kernel just to show you it's not using the other previous version I had there. And so we go to our cloud loading, hit here, load the package, and go get hit by our bug again of opening all the sections. There we go. Ouch. Sorry, we will fix that. And now we can actually see we've loaded this package directly from the cloud. Okay, so one of the things that we've got with this, we've got a problem that we don't want some people to just have to load up a package and click the initialization button. That's kind of ugly. So what we want is we want this to happen automatically. And so we've got this loading stuff here, but since it automatically loaded, let me show you that again. It was a bit too fast. I'm going to, again, quit the kernel, nothing up my sleeve, starting from scratch. We have our auto-loading of packages. And right there you see it loading, 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 loaded. OK, so what happens is what we did is this dynamic, when it's actually loading up, will automatically turn around and kick off a computation. And so there's some dynamic junk here to just make sure the background's green and it looks nice and it has the right bits. But the real magic here is just basically this dynamic. If it doesn't have a value, load status doesn't have a value, it sets it to loading, and it does this session submit of pause of blah. So this pause is our stand-in here for loading a package. It could be a needs, it could be a cloud get, or so on. But it's using the session submit. And if you went and you listened to Roger talk about this, the session submit gives us a way to an end to do concurrent programming. And so we can sort of say in the idle time while the kernel's idling, it can go ahead and actually do something like load up a package in the background. And that's quite nice, and it sits around. So this would be one of the things we need to actually have external loading of an actual package. OK. So now let me just sort of switch gears a little bit and actually talk about peer-to-peer lending, and so that we can actually build up this application to do with this. So first of all, we have to talk about what's traditional banking. Well, we normally have a lender, a bank, and some borrowers. And what happens is the lender turns around and gives the bank some money as a term deposit. The bank will turn around and give that out to, they'll collect up a lot of that and then give it to some people as a mortgage. And the borrowers will then, over time, have to turn around and say, make monthly house payments. They're wage slaves to pay off their mortgage. And in the end, the bank will take a fraction of that and give it back in interest payments to the lender. And so that's all well and good. Everybody understands that, except, of course, let's say when the borrowers have some problems, the economy goes a little bit south, some of those people lose their jobs, they can't make payments to the bank doesn't have enough money to give to the lenders all turn around and say to the bank, give us all our money, there's a run on the bank blows up, and then we get the global financial crisis, and it's all bad. People don't like that. So there's fintechs have come up with some of the financial wizards out there have come up with this peer-to-peer lending. And so instead of this normal model of a lender, a bank, and some borrowers, what they do is they basically get rid of the bank. And they move to where we have a whole pool of lenders, a whole pool of borrowers, and this peer-to-peer organizer. Basically, they're a matchmaker. And so what happens if borrower number one here wants a loan for $20,000, the various lenders here, along here, they all give a small amount. Lender 1 might give $25, lender 2 might give $50, lender 3 might give $25 again, and so they all give various amounts to this borrower 1, and the borrower 1 actually turns around then and gives some interest and principal back to all the various lenders. And so these lenders, since they're only giving small amounts of money, $25, you might have 400 loans. And indeed, in our peer-to-peer portfolio, I've got like 100 loans out there at the moment. And so if borrower 1 now becomes bankrupt, he goes charging off and lives in his mother's basement and decides not to give us any more money, what happens is I've only lost 1 of my 400 loans. And so it's okay that you can actually sting that sort of loss. And of course, as time goes on, or the other borrowers come up, so like this borrower 2, maybe lender 2 here doesn't really like the look of this loan, and so lender 2 doesn't loan it. And of course, borrower 2 only pays back the interest and principal to the lender 1 and lender 3. So the system, of course, is much more insulated for the organizer here. If the loans go bad, it's only the lenders that have problems, and the central organizer won't become bankrupt, and we won't have global financial crises. And so that's the idea behind peer-to-peer lending. And so the question is this risky? And so here's this cheesy sort of ad they had for the peer-to-peer lending, and we've got nice little smiley, you know, in the literature, well, in the advertisements, you've got nice little smiling investors and a smiling borrower, and everything looks nice and smiley and happy, but of course, it's somewhat new, and it might all come down in some flaming pile of bankruptcy, and it might be really bad, and there are definite risks. So I won't talk about, you know, the economy changing and all of those things so much. So let's talk about peer-to-peer lenders. In America, Lending Club, Prosper, Upstart, Funding Circle. I'm a citizen of New Zealand, actually, New Zealander, and so they've got this in New Zealand. Harmony, it's unsecured. In other words, the people borrowing money don't need to put up their car or house. It's fractionalized. Squirrel money is somewhat similar, but it's secured, and it's a little bit different. And so there's these various variations, and I'm going to talk about Harmony. Okay. So let's take a look at some example peer-to-peer loans here. I don't know if people can actually sort of read this. I'll read it out. Here's one of the loans that you can actually see that comes up in Harmony. Here it's an E3 loan, so it's a bad grade, but they're paying 25.6% interest. It's over 5 years. It has an expected default rate of 4.38%. So that's the percentage that they might just run off. And this person is asking for $8,700. He's for household items, and he's giving his reason here. I am moving into a flat. That's, for the Americans, that's an apartment. I'm moving into an apartment. This money will help me furnish my room, also helping me repair my car, and I also intend on taking a holiday to Fiji. Thanks. So we might take a look at this and think, I don't know. So this guy's borrower's income here, $1,700. He's borrowing more than 10% of his wage here. He's living in a place called Huntley. He's still with his parents. Of course, that's why he wants to move into an apartment. Yeah, maybe I'll fund him, maybe I won't. And so you see these various loans like this. Here's another one. It's a B3. It's got 14.49% interest. It's only got a default rate of 0.21%. So the interest rate's gone down, but the default rate has really gone down as well. Strangely, of course, he's listed his reason as a computer, and he wants to borrow $32,000, and he's 59 years old. Maybe he's buying a rack server. I don't know. You'd take a look at various details and so on. And so you can see these various different loans. D5 paying 22.9%, 2.6% default rate. And a C1 here, paying 16.49% and a default rate. So now, you being the mathematical type people that you are, you wonder, well, these people are possibly defaulting at various times, but they pay a higher percentage. What's the optimal way that I should structure my portfolio so that I make money? So to simulate this, what we're going to do is there's 3 things that can happen for any investor. 1, the investor in any 1 month can make a payment. 2, they could actually pay everything off. Or 3, they could go bankrupt and pay us nothing. And so then this is just basically a simulation of collecting up all the interest payments, reinvesting them over time, taking the fraction of money that Harmony scrapes from us, paying some taxes and doing some other bits. And so we need to simulate this all over time. And so here's the simulations. Here's just the code. I'm not going to talk about it too much. I'm just sort of saying there's a parallel table here. And what we're doing is we're basically getting 3 data sets. Just grade B2 by itself, grade B5 by itself, and grade B2 and B5. And so each one of those, to run that on my laptop takes about 10 minutes to actually generate those, and we can get some really nice visualizations. Really nice visualizations here, and see what's going on. So here we see our B2 grade. It's quite secure. There's a very low default rate, so quite a lot of the time you'll actually hit the perfect thing where nobody defaults at all. So we get a nice big spike right there at 11%, paying 11%. But then every so often, some people are, when we simulate it, are going to default. B5 will also get a reasonable spike. Some of the time, you'll actually get it through in B5 that no one will default, but it's less likely, and so that level there is lower than there, and then you get this sort of distribution curve. And here, excuse me, is the combination of the B2 and B5. And you note you just can't sort of add those things, so we've somehow got to put this all together and simulate this in a nice way. And I have just lost the clippy bit. Right, I'll just hold it there. So we've somehow got to put this all together in a way on the iPad that we can actually have some interactivity and simulate this. So what we're going to do here is put this together and take a look. And I'm going to turn my iPad like so. And we are, in fact, just to show you I've got nothing on my sleeve, I'll quit the kernel here and show you that this loads like so. And we can see the loading, and it's already loaded here. And here we've got a selection of various grades that we're going to simulate, and we can just set this running here. And now we can actually see this over time. Sorry, we can actually see what's happening, and we see we're getting right here a sort of return of about 15.5 plus or minus maybe 0.5% with this selection of grades. And so, of course, we might be a bit more of a bottom feeder. We might just go down and really get some really nasty grades here, the E grades as well. And so you notice as I change this, we're regenerating this. We're going to have new results. And we see our return, our average return's gone up. But, of course, we're getting a bit more of a spread. And over time, this will actually build up. We do have in here the application, we have this charge-off multiplier. And so that's basically to model if economic conditions get a bit worse. So in other words, let's say the default rate goes up to maybe twice. So there's twice as many people, the economy's tough, twice as many people are defaulting on their loans as before, and now we can see we've decreased our rate of return. And so we're giving some instant feedback. And so this has sort of put the whole thing together, and I want to just sort of say, I'm going to quit this here again, and we note here in the player, worry, the player here, it's remembered our selection. So here we're using local storage from before, the same technique that we built up to actually remember what were the selected grades that we're actually running. And it uses the same technique to get this loaded to actually load the package. And so these are the basic steps that we need to start building the application. I could have made it more complicated, but then my notebook would have been a little bit harder to follow. So I've sort of left it here, but of course we might have some input fields, store some stuff in the cloud, take an order, and we say to some clients, yes, would you like to invest in this right now, or so on. And so we can build up more complicated applications on the iPad. Okay, well, that brings me to the end of my talk.